friends, welcome back. Today we are going to solve one very interesting and important coding interview question. Smallest subarray with all occurrences of most frequent element. So I recently came across this coding problem and I solved this coding problem. This is quite interesting coding problem. So I just thought that it's worthwhile to create a video and show you guys how we can solve this kind of coding problem. So we are going to go through this example problem. We are going to understand this problem with few examples so that you will completely understand the problem. Also make sure you watch this video until the end so you completely understand the logic of this problem, right? This is quite important coding interview problem. Before we start looking into the problem details with few examples, I would like to quickly mention that this channel is to help people in their coding and Java interviews. On this channel, you will find more than 500 different varieties of coding problems, which are taken from previously asked coding interview questions by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big companies. Many of those coding problems are very important coding problems of different types, like graph problems, matrix problems, problems related to breadth first search, depth first search, strings, linked list, optimization problems, dynamic programming questions, binary search tree coding questions, as well as lots of logical coding interview problems are discussed, solved, and explained on this channel with examples for your easier understanding. Apart from that, you will also see a lot of data structure related very important coding interview problems are also available on this channel to help you. For example, questions related to stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, as well as many more important data structure related coding problems are also available on this channel. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, or you simply want to learn more different computer science concepts, paradigms, data structures, algorithms, problem solving, Java programming and coding, then this channel can definitely help you in doing so. So please subscribe to this channel now. Also, whenever we come across any interesting and important coding problems or coding challenges, we often create videos on this channel to discuss those problems along with the approach, logic, and the Java solutions, so others can also learn how to solve different varieties of coding problems. Others can also learn how to use different data structures and algorithmic techniques to solve different coding problems along with the Java programming language. So make sure you click on the bell notification icon right away so you won't miss any important upcoming interesting videos from this channel. So let us start with this interesting coding problem: smallest subarray with all occurrences of most frequent element. So we'll first go through the problem statement so it will be clear to you. Given an array A, let X be an element in the array which has maximum frequency. The task is to find smallest subsegment of the array which also has X as maximum frequency element. Note, if two or more elements have the same frequency, that is maximum frequency, and the same subsegment size, then print the subsegment which occur first in the array. So this is what the problem statement says. So implement function smallest subsegment that takes array size of array n and return the required subsegment of the array. The driver code will take care of printing it. On and on is time and space complexity. So let's first understand this with this small example. Then I have created some bigger examples for our discussion. So basically, as you can see, this first example, they are saying that we have to find out a subsegment which is smallest, but it should have the maximum frequency numbers. So for example, 2 is the maximum frequency number in this array, right? 1 is also having same frequency, 2 is also having frequency 2, but 2 occurs first, right? 2 occurs first because 1 is not occurring first, right? So 2 occurs first, so we have to print this 2 comma 2, this array, right? 2 and 2. So this is what they are saying. Now in this second case, the frequency of 3 is 2 and frequency of 5 is also 2, but 3 occurs before 5, right? So we have to print 3 and 3, right? That whole segment we have to print, sub-segment basically of the array, right? So this is what the problem statement says. Let's understand with some more examples. So this example we have just seen, right? So we will talk about a bigger example that I created. So let's talk about this example, right? Now in this case you can see that the maximum frequency number in this case is 5, right? 5 has a frequency 4, right? 5 appears 4 times here, right? 5, 5, 5 and 5, right? So 4 times. 3 appears 2 times, so it's not the maximum frequency. So what they are saying is we have to extract this part of this array which actually includes the 5, right, which is the maximum frequency element. So this is the answer we have to return basically. So the problem statement is clear, right? So with these examples, in this case both 3 3 and 5 5 has same amount of frequency, but 3 appear first, so we will just have to return this one, this part, right? 3 and 3. So now the case becomes more interesting when we have multiple numbers with same frequency. For example, like this, right? Now in this case 3 has a frequency 4, 3 has a frequency 4, 5 also has a frequency 4, correct? 3 appears 4 times, 5 appears 4 times. So which one should we take? If we take 3, then this is the subsequent that we have to take. The length of this subsequence is, or subsegment is 6, right? This is 1 2 3 4 5 6. But if we should take the one which has least amount of length, right? This is the least amount of length, right? Its length is 5, right? 1 2 3 4 5. So this is the one we should take, right? Because it has smallest sub array. They want smallest sub array. The title also says that smallest sub array, correct? So this is why this is a smallest sub array we have to choose, right? So it is clear now to you, right, what the problem is. So we have to implement our solution in such a way that it can handle all these cases, right, when there are tie between the equal amount of frequency. So let's discuss how we will be solving this problem. So what we will do is we will need a couple of things to solve this problem. First thing we have to also take care of is the number and its frequency. So for that we will create a frequency map, right? We will create a frequency map for that, right? So it will tell us the number and its frequency. So let's say let's just draw one sample frequency map for this one, right? So the number of frequency for 3 is 4, number of frequency of 1 is 1, number of frequency of 4 is 1, correct? And number of frequency of 5 is 4, and number of frequency of 6 is 1, correct? So we are just writing the number, how many times it appears, right, in this array. So this is a frequency map. We also need to keep track of the starting point of each number, right? So we will need another map which will keep track of starting point, right, of each number. So starting index, in essentially it is a starting index for each number, right? So let's just have one sample map here. So it will be clear, right? If we go through this example, it will be clear for you to understand the code. So for example, the index for 3 is 0. So 3 starts at 0 basically. That's what it means, right? 1 starts at 2. 1 starts at 2, 4 starts at 3, correct? 5 starts at 4, starts at 3, 4, 5, 6. So 5 starts at 6 and 6 starts at so this is 6, 7, 8, 9, right? So this starts at 9. So these are the indexes for that number, right? But why do we need to keep track of the index? We need to keep track of the index because whenever we see the same number again, we need to calculate the subsegment length, correct? So for example, when we go here, let's say, right, when we go here, we know that it appears first time here, right? So we can easily calculate this subsegment length, right? Because we know the index here, we know where it appeared first time, so we can calculate this total length of that subsegment, right? That's why we need this starting index map. So these are the two maps we need, correct? And we will always keep track of the highest frequency number we have seen, correct? Highest frequency number also we have to keep track. So I'll just write down here highest frequency number, right? So what is the highest frequency number? Let's say we are going like this, right? 3 3 1 4 3 and 3. So we are here, so frequency of 3 became 4, so we will just say that the highest frequency we have seen so far is 4, correct? Now we started to see these numbers, right? 5, 5, 5, 6 and 5, correct? Now when we are at this point, we also notice that the frequency of 5 is again becoming 4, right? It is same as our highest frequency, what used to be, right, for 3. So now this is an important point to understand, right? That we have to now calculate the subsegment length, because both have same frequency. 3 has frequency 4, 5 has frequency 4. So now if we are finding out a segment which has a smaller length, then we are going to pick up that one, correct? So for example, this one is smaller now, right? Because it starts here and it ends here, right? So the length of this subsegment is 5. So we'll calculate this length of this subsegment. If it is smaller than this subsegment length, which used to be 6, then we are going to pick up this one, right? And we will keep track of the starting index, right, and ending index, correct? So we know what is the starting index where 5 started. Because of this map we know. So we know it is started at 6, and we know that it is ending at 7, 8, 9, 10, right? It is ending at 10. So once our code reaches the final step, then it has captured the starting and ending index of highest frequency number in such a way that we have smallest sub array, correct? So this way it will give us the smallest sub array. So when we reaches the end of the our code, then we will just use this information to extract these numbers from this array, right? 5, 5, 5, 6, 5, because 5 is the highest frequency number in this array, and it is the smallest sub array length, right? So that is how we are going to solve this important coding problem. I hope you understood this logic clearly now. So we are going to need two maps here. So frequency map is to keep track of the frequency, then starting index map is to keep track of where that number appears first, the index of that number, where it appeared first in the array, right? And then we will also keep track of this highest frequency numbers, right, so that we can calculate the smallest sub array. So it is clear now to you with this example. So we'll just go to the code now. So our method that we are implementing is a smallest subsegment. We are going to return array list of integers, right? And we are going to get array as an input. We are going to get n, which is the length of the array. Now we will first create an array list of integers here, because that is what we will be using at the end to return. This is what we will return at the end. Okay. So we will create two maps as we discussed, right? One is for frequency. So this is having integer and integer as a key and value. Why integer and integer? Because the key is going to be the number, right, in the array, and the value is basically frequency of that number. So both are being integers. The key and value is integers. Now the next thing is start index map, right? So this is to capture where that number appeared first time in the map, right? So again it is integer comma integer. The key is the number and this value is going to be its starting index. So these are the two maps we have created. We will need couple of variables, right? The highest frequency, start index, end index, maximum length. So all these are 0, 0, 0. We have initialized it, right? So these are some variables that we'll be needing basically during the implementation, right? So we'll just create those variables. Now we start looping into this for loop, right? We'll go through each of the number in this array and we will check. So we will check if the frequency map contains that number, then we are going to increment its frequency by 1, correct? So we are going to increment the frequency by 1 if it's there. Otherwise we will add a number with frequency 1, correct? And we have to also add it into the start map, right? Start index map, because it is appearing first time. So we will add the number and its starting index here. So this part is clear to you, right? So this way we are actually handling the frequency map and starting index. Now next thing we will be doing here is we wanted to check if the frequency map for that current number, right, the current frequency for that number is more than our highest frequency that we have seen so far, right? If it is more, then it means that we are seeing a more frequency number, correct? So this is clear, right? We are seeing a more frequency number because it is greater than our highest frequency. So we have to update the highest frequency basically, correct? How we will update it? We will just get it the current numbers frequency from map. We will assign it to the highest frequency. Now we have to also update the start index. So start index will be the index of that number which we are currently on, because it is now the highest frequency number, correct? So we are having this start index. End index is I, because that is where we are currently are, correct? And then we have to calculate the max length. How we'll calculate it? We know the end index, we know the start index. So we have to just do end index minus start index plus 1 will give you the length, which is called as maximum length for that highest frequency number. So this part is clear to you, right? What we have done. Now, in this else if, we will check if the frequency of that current number is actually equal to our highest frequency. For example, here, right? So 3 has a frequency 4, 5 also will have frequency 4 once we reach here, right? So both have frequency, same frequency 4, for example, right? So what we have to do, we have to now calculate the current length of the sub array, right? So current sub array length we will calculate, correct? I minus start index of the current number plus 1. It will tell us the current sub array length, right? For example, what we are doing here is we are calculating this length of this subsequence, right? So I'll just remove these things so it will be clear. So we are calculating length of this subsegment, right? 5 is the length, right? So that we know this length is 5, we know our previous highest length was 6, so we have to update it, right? So this is what we will do. So we know the current subarray length when we are seeing another number with the same highest frequency, right? So we will know the current subarray length, and we will check if current subarray length is less than our maximum length, correct? It means that we are seeing some another number with the same frequency but having smaller length, correct? Having smaller length. This is what exactly I shown you like this, right? In the blue color. So if that happens, then we have to update our highest frequency will be equal to the frequency of the current number, right? We will update start index with the current numbers start index, correct? End index will be I, where we are currently on, and we have to update the maximum length, which we will calculate end index minus start index plus 1. Again, for example, in this case it will become 5, right? It used to be 6, now it will get overwritten with 5, right? It will get overwritten with 5. That is what we are doing here, right? So as you can see, this comment that I wrote, we are getting smaller length sub array, so we have to update max length, right? And also start and end index for the sub array, because we are going to use that start and end index at the end to extract the elements from the array, right? So we have to manage that here. So once we go through this for loop completely, we will know the start index and end index. For example, this is the start index, this is the end index, right? Once we know that, we can extract those numbers now from this array. So that is what we are going to do in this for loop. Our I will start at start index, our I will go until end index, right? We'll go extract all those numbers, put it into the list and return the list here. So this is the whole solution. So I hope it is clear to you. So it's not that difficult, but it's little bit tricky for the beginners or freshers or junior level developers. But this is a pretty clean solution that I wanted to show you, right? With this frequency map and start index map. So as per the expectation, the code has a time complexity is order of n because of this for loop, and the space complexity is also going to be order of n because we have used maps, right? So now let's go ahead, take some examples, make sure the code will work correctly. So let's compile and run. So we are going to be running it with their first test case, right? So the code is being run. So 3 and 3, which is correct answer. So this is actually having it is having same frequency as 5, but it is appearing earlier, right? So now let's do one thing. We'll put 8 numbers. Let's put 5 here and let's put 8 here, right? So now in this case 5 has more frequency, so we should get these 3 5s. Let's take a look. So as we can expect, 5 is what we are getting, which is correct answer. Now we are going to try our examples, right? So we'll try this example: 331433, 331433, and then 55565, 5556 and 5, right? So how many numbers are there? This 6 plus 5 is 11 numbers are there, so we'll have to put 11 here. So we are expecting that it should find out this one, right? Because it has 4 frequency and is the smallest segment. So our code is getting evaluated. So as we can expect, we are getting correct answer, right? We are getting correct answer. Now let's modify this test case. Let's put 12 here, right? And we add one more 3 here, right? In this case, 3 will have more frequency because it appeared 5 times. So we should get this one that I highlighted, right? Let's make sure it works. So we are getting correct answer, as you can see. So we are getting correct answers. We'll just go ahead, submit this code snippet. We already talked about the algorithmic time and space complexity. Our code is getting evaluated against 105 different test cases, and all our test cases got passed, as you can see here, and code got successfully accepted. So this is the way you can solve this smallest subarray with all occurrences of most frequent element, one medium to difficult level coding question. And I wanted to show it to the freshers as well as junior level developers how these kind of questions we can solve using hash maps, right? How we can use hash maps to solve this kind of problems, how we have kept track of the frequencies, how we have kept track of the starting indexes using map, right? So I hope you learned something new by watching this video. You learn how uses of hash map to solve these kind of problems, and you understood the logic with this explanation and examples, right? Um, if you are new to this channel and if you haven't already checked the very important playlist on this channel about coding interviews, then I would like to mention that there is a very important coding interview related playlist for you on this channel. It is called as Leetcode and Leetcode Solutions. That playlist is very important because it captures more than 250 different varieties of coding problems. Those are the coding questions compiled together under one playlist. Those are the questions that got asked many times in many interviews by many big companies. So make sure you go through those videos, make sure you check out those problems and understand the logic and the Java solutions. It is also important for you to understand how the Java code is implemented for those problems, right? There are many medium to difficult level problems are also available there to help you understand how to approach medium and difficult level problems and how to solve them. If you go through those videos, if you check out those problems, you are going to learn a lot of data structures, algorithms, problem solving, logic building, how to approach and solve difficult coding problems, and how to implement their solutions in Java. So you are going to learn a lot of Java programming and coding also there. You will also come to know what are the frequently used Java classes, APIs that we often need during the implementation of different concepts and different solutions. So it will help you a lot in your coding interview preparation process. So make sure you check those videos out. The name of that important playlist is Leetcode and Leetcode Solutions. Now if you still want to practice more coding problems for your learning purpose or for your practicing for your interviews, then there are 3 other main playlists available on this channel. The names of those playlists are Code Forces, CodeChef, AdCoder. Code Forces, CodeChef, AdCoder. More than 500 problems are available for you on this channel to help you in your interview preparation and learning process. So make sure you check out those videos. Apart from a lot of helpful coding interview related videos, you will also see a lot of relevant Java J2EE specific interview related videos available on this channel to help you. For example, frequently asked telephonic Java questions and how to answer them, Java design patterns, Java architecture, questions about SQL programming, as well as Unix and KSH shell scripting to the Java developers. Because as Java developers, we often get asked other auxiliary technology specific questions in the interviews. For example, SQL programming questions, Unix commands, Unix utilities, shell scripting questions. In the SQL programming, you will get all important coding questions varieties also available. For example, different types of joins, different types of constraints, primary key, secondary key, unique key, all those different concepts, how to write triggers, everything is available in the videos. So make sure you check out those important videos as well. If you like this video, if you find this video helpful, if you like the way the video is created with this whiteboarding session examples and Java code, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Your subscription is very important for the channel because that is the way the videos can reach to more people who need help in solving coding problems. One of the main goal of the channel is to help people in their coding problem solving and in general their interview preparation and learning process by creating content that others can use to prepare well for their coding rounds, as well as they can use to learn more data structures, algorithms, problem solving, logic building and Java coding. So if you like this video, give it a like, share this video as much as you can with your friends so they will also watch and learn from these videos. If you like the videos on this channel, if the videos on this channel are helping your learning process and your coding interview preparation process, then don't forget to mention that by writing comment on these videos. Your comments are very important for us. That increases our motivation to create more such good quality content. So if these videos are useful and helpful for you, then do mention that into the comments. Whenever we come across any interesting and important coding problems or coding challenges, we often create videos on this channel to help others also understand and learn how to solve those problems, and to help others also in their learning in data structures and algorithmic techniques and Java programming language. So make sure you click on the bell notification icon so you won't miss any important postings that are going to be coming soon on this channel. I'm going to add this Java solution in my GitHub account project, and I'll give you the link in the video description so that you can check out the code, play with the code by creating your own custom input test cases for your better understanding how our hash map based solution works for this problem. If you like the Java solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. Keep learning, keep coding, keep solving more varieties of problems, and most importantly, keep your learning process going on continuously. And thanks for watching this video.